First of all, thank you for joining us today in this webinar dedicated to microservice architecture. I'm happy to have you all here as we dive into the transformative approach to software development. And let me introduce myself. My name is Roman. I am a web developer at Agiliway company, and I have been working in this company approximately 9 years. And today I'd like to share my experience with you. My topic today is advantages of using microservice architecture for building the robust and scalable system. So let's break down what you can expect from today's session. My presentation structure is as follows. First of all, we will start with what is microservice architecture and why is it so popular in the world of development. After that, we will review the key characteristics of microservices. Next one is advantages of microservice architecture. I briefly overview of the advantages of the microservice architecture. After that, we will, in this section, we will consider application architecture and compare them. After that, it will be the security in the microservices. We will talk about the types of microservice security. Next one is the microservice design patterns. We will also very briefly review the microservice design patterns. And finally, if you don't mind, we will have a question answer session at the end of our talk. What is microservice architecture? Microservice architecture is the way of designing software system where the application is composed of many small independent services that works together. Each service focused on the specific business function like user authentication or order processing, and can be developed or deployed and scale it independently. And this approach makes it easier to update and maintain the application, since changes to one service don't necessarily impact other. To put simply, microservice architecture is like the building the application out of the Lego bricks. And each Lego bricks present a small self-contained service that performs a specific function. And these bricks, I mean the services, can easily connect it to build the complete application. And if you need to update or replace one bricks, you can do without disrupting the other. This approach allows for more flexibility compared to the traditional monolithic architecture, where all functionalities are integrated into one large blocks. So let's go through the main key characteristics. So the main key characteristics of microservice architecture, first of all, it is a decentralized data management. Decentralized data management in the microservice architecture involves each microservice owning its own data and database, and each service can scale it independently, choose the best database technology, and ensure high availability. So this approach promotes service autonomy and scalability, but requires careful design and implementation of the data consistently, synchronization and management. And using the pattern like event sourcing and the right tools can be manage these complexities effectively. Next one is independent deployment and scaling. And independent deployment and scaling are foundation principle in the microservice architecture aimed at enhancing system flexibility and performance. This architectural style decomposed the monolithic application into the collection of loosely coupled, independently deployed services. And organization can build the robust and responsive system that adapt efficiently to changing the business requirements and user demands by allowing service to progress and work independently. However, the benefits come with the need to effectively management of the complexity of the distributed system. Next one is the use of lightweight communication protocol. This architecture relies on a lightweight communication protocol to facilitate effective interaction between the services. Unlike a traditional monolithic system where components communicate within the single process, microservice requires inter-process communication across the distributed environments. Protocols such as HTTP, HTTPS with RESTful APIs, gRPS, and the messaging protocol like the MQTT are commonly used to meet these needs. And despite their benefits, using lightweight communication protocols requires careful consideration of security, data consistently, and error handling to ensure robust and reliable service interaction in the system. And the last one key characteristics, it is the technology diversity. Microservice architecture promotes technology diversity by allowing teams to choose the most important language frameworks and the tools for each service, optimizing the performance, development speed, and maintainability. So there are a lot of characteristics, but we have reviewed the main of them. Let's review the main advantages of microservice architecture. Today we are going to pay attention to two of them, that improve performance, reduce cost, and support handling of the varying loads. So first of them is scalability. So as we talked before, each microservice handles a specific business function and communicated with the other through APIs. This separation allows for target scaling of the individual component based on their load and the resource requirements, rather than the scaling the entire application. And the microservice also enable the use of different technologies and optimization for each service. This allows individual service to be scaled independently and enhance the performance during the peak loads, or the optimize the source utilization without affecting the entire system. For example, scaling the e-commerce applications payment service separately without impact to others microservices. Next one is robustness. The microservice architecture enhances robustness by breaking down the application into the smaller, independent service that can be developed, deployed, and scaled independently. So as we talked, each service focused on the specific business function, enabling the better failure isolation. If one service fails, it doesn't necessarily bring down the entire system, ensuring higher working. Robustness is further enhanced through the redundancy, where the critical services can be duplicated and the load balanced. Additionally, microservices often incorporate automated monitoring and recovery mechanisms, allowing for quick detection of issues. This modular approach also facilitates continuous integration and deployment, improving the overall system reliability. So, for example, it can be isolating the issue in the user authentication service, like example, yeah. And these two main advantages of microservice architecture. Next slide is application architecture. Now I would like to talk with you about the application architecture. What is the application architecture and the difference among architectures? The application architecture refers to the design and organization of the application components and services. It defines how these components interact, communicate, and are deployed. The key aspects including structure, interaction, scalability, security, maintainability, performance, and reliability. So the component style, including maybe the monolithics, microservice, serverless, and the SOA. I guess let's review each of them and compare them. The monolithic architecture is a traditional approach to software development, and monolithic architecture is an architecture pattern of designing and developing the complete application at the single unit. For example, traditional application will have the front-end, API, services, load balancer, and databases. And if you build everything together and deploy it on the server, that's called the monolithic architecture, where the service tightly coupled together. The second one is the service-oriented architecture, very similar to microservices. The service-oriented architecture is designed approach where the software components are organized as the collection of the loosely coupled. Each service represents the specific business functionality, and they communicate with each other through the well-defined interface and the protocol. So typically using HTTP or message queues. So SOA promotes reusability, scalability, and flexibility, allowing organization to build the complex systems. And this architecture supports interaction across different platforms and technologies. Next one is the serverless architecture. Serverless architecture allows you to build and run the application and service without the need to manage the infrastructure. Also, your application operates on the servers. You don't have to handle the server management. So let's compare them. And first of all, it is scalability. Microservice has high, I guess, independent scaling of service. Next one is SOA, and may need to scale multiple services. Very high level is for serverless and automatic scaling based on the demand. And the last one is the monolithic low, because the entire application must be scaled together. Next one is the development speed. microservices has high as well. It is because the parallel development of services, SOA moderate, requires the coordination, but supports the parallel work. And serverless high, it is because the fast development for simpler functions. And monolithic low, changes required redeployment of the entire applications. Yeah, that's the reason. Next one is the failed isolation. Microservices failures in one service don't affect others, therefore high. SOA moderates the better than the monolithic, but not as isolated as microservices. Yes, serverless high, failures contained within the individual functions. And monolithic, as usual, low. Failure in one components can affect the entire application, entire project, we could say. Next one is flexibility. Microservice high, because different technologies and language can be used. SOA moderate, standardized across the services. Serverless high as well, because support the multiple runtime and languages. And monolithic low, typically used the single technology stack. And the last one, and the last one is the deployment. Microservices independent, services deployed separately. SOA more coordinate. Service can be deployed independently. Serverless independent, because of functions deployed individually. And the monolithics, the single unit, entire application deployed together. As we can see, the microservices has high, a lot of high level. So one of the most important things is security. Security in microservices architecture is the critical aspects that involves protecting each microservice and the data in handlers. The application design and implementation phases involves numerous security challenges that must be solved. So the key security requirements, such as authentication or authorization, must be addressed during the design phase. So application security architecture must understand and effectively use established architecture pattern to implement the authentication and authorization in a microservice-based system. Let's talk about three of them. First level is edge level authorization. In simple cases, authorization can be managed solely at the edge level. We could say the API gateway. By using the API gateway, you can centralize the enforcement of authorization for all backend microservices. This removes the need to implement the authentication and access control for each individual service. A highly effective method is mutual authentication, which prevents a direct unauthorized authentication access to the internal service, ensuring that the API gateway is not bypassed. And typically, development team implements authorization in the two location. It is H, as we said, it is the API gateway and the service level. Service level. Service level authorization is the microservice architecture involves managing and enforcing the access control at the level of the individual services. This is the crucial for ensuring that the only authorization service or using can be accessed special functionalities or data, maintaining the security of the system. As you can see on the screen, there is a policy decision point. We can call it PDP, and we could say it's compute the access decisions by evaluating the applicable access control policy. And we can see the policy enforcement point, PEP. It's enforcing the policy decision in the response to the request from the subject requesting to the protected object. And for example, service level of authorization in the AWS Lambda can be achieved using the IAM policies to control the access to the specific AWS services. On the slide, you can see examples of the policy for AWS S3 bucket. As you can see on the slide, you should fill in the information about the effect. It could be the allow or deny. It is the action what we would like to do. I mean, the S3, we would like to get the list of buckets, get just item or some another action. And the last one is the resource. Yeah, it is the name of it is resource of our bucket. And the third level is service-to-service authentication. It is the crucial aspect of security in microservice architecture. The most popular of them is the token-based authentication and mutual transport layer security. First one, I mean the token-based. The token-based approach works at the application layer. A token is a container that may contain the call it ID. We could call it like the microservice ID, and its permissions. It is our scopes. The caller microservice can obtain the signed token by invoking the specific security token service using its own service ID and the password, and then attach it to the every outgoing request. It could be, for example, via HTTP headers. Yeah. The caller called microservice can extract the token and validates it only online or offline. Yeah. Mutual transport layer security with an TLS approach, each microservice can truly identify who it talks to, in addition to achieving the confidential and integrity of the transmitted data. And each microservice in the deployment has to carry a public and the private key pair and use that key pair to authenticate to the recipient microservice via MTLS. MTLS is usually implemented with a self-hosted public key infrastructure. The main challenges of using MTLS are key provisioning, the trust bootstrap, certificate revocation, and the key rotation. Yeah, that's the challenges. So our last point is microservice design patterns. I'd like to tell you about it as I believe it is the useful information for you, and it's rather the summary of everything that we have talked about. First one is API gateway pattern. The API gateway pattern is essentially for managing communication between the client and the microservices. It serves as a single entry point for client requests, routing them to the appropriate microservices. So, and implementing API gateway pattern for large application with multiple clients offers significant benefits. I would say, yeah, it provides a single entry point for microservice and wrap the clients from the service partitioning. And the pattern simplifies the client interaction by acting as a reserve the proxy and the allowing service boundaries to change independently. And it approves functional design for specific client types, reduce round trips, and handles tasks like the authentication, SSL termination, caching, and enhancing the security, or you could say the protection. And API gateway also improves the security by reducing the attack and efficiently managing authorization and SSL. And additionally, it decouples the internal microservice from the client apps, allowing the partial request access, even if the microservice fails using the caching to return the response or validate error codes. Next pattern is the circuit breaker. Circuit breaker pattern improves fail tolerance and the stability. It prevents the cascading failures by monitoring the service calls and the operating the circuit when the failures reach the thresholds. I would say the circuit breaker pattern is used between the service communication synchronously. It helps prevent the system-wide failures when the service has a high latency or it's unresponsible, avoiding resource pile up and the delays. When implementation the circuit break function, monitoring failure conditionally and the trip then necessary. After the tripping, all calls result in the error and are redirected to the different service or the default error message, ensuring the system remains stable despite service issue. Next one is the event sourcing. Event sourcing involves storing the state of the service as a sequence of events. Instead of storing the current state directly, each change is recorded as an event. And event sourcing design pattern is used in microservices to capture all changes in the entire state. It employs event stores, which can also function as a message broker to ensure reliability and stable communication between microservices. The pattern stores are series of state changing events and can reconstruct the current state by replaying these events. Event sourcing is particularly useful when the transactions are critical or when avoiding the changes to the existing data layers code base is necessary. And the last one is Saga. Saga is a series of local transactions. In microservice application, Saga pattern can help maintain data consistently during the distributed transactions. On the slides, you can see that we have two transactions. First transaction is the we would say the pay transactions. Yeah, this transaction consists of create order, update inventory, process payment, and the delivery order. And the second one is compensation transaction and consists of refund money, recall products, and the cancel order. Before diving into microservice architecture, your team needs to plan your journey. To get started, identify the boundaries of each of your services. And excellent methodology for scoping services is domain-driven design. And when transitioning of the microservice, it's essentially to decouple your modules to the teams can work on different services without impacting other. It's also fundamental to understand that microservice involves a distributed system, which comes with the challenges. You need to factor this in your planning, I guess. And microservices need to communicate with each other, so you need to ensure that inter-service communication doesn't come a bottleneck. You can choose between the synchronous or asynchronous communication methods depending on your application needs. And a service mesh is the dedicated infrastructure layer for making service-to-service communication safe, fast, and reliable. So if you are using the microservice architecture, consider using the service mesh such as Astio, Linked, and the Console Connect. That's my advice. So that's it. If you have some question, let me please know.